go 4x plus 3y equals 6. So 4x plus 3y equals 6. So that's one equation. Let's go with another one as 6x equals 9 minus 3y. And we've been talking about how it's useful to solve. We've got a couple routes here. I'm going to keep talking about this idea that we've got multiple ways we can solve these things. Could we solve this equation for y and put it in y equals mx plus b form? Solve that one for y, put it in y equals mx plus b form. And you got two equations in y equals mx plus b. So then since the y's are the same, take the mx plus b's and set them equal to each other and you can solve for x, right? So we've done a couple of those. Okay. You could look at one of those. Could I solve the top one for x? And then substitute that into the x in the bottom, right? I could solve the top one for y and do the same thing. Now, if you do that, if you take the time to solve either of those for x and y, you're going to get fractions in that top one. Okay, so if I solve for y, for instance, I'm going to get negative 4/3 x plus 2 as my y. And maybe we don't like fractions. Okay. If I look at the bottom one, can I do the same thing in the bottom one? Can I solve that first one for x, or solve just by dividing everything by 6 and get x? And if I do that, I get 9/6 or 3/2 over or minus 1/2 y. So I get fractions again there. But I could solve. Let's think about this. Could I solve this bottom one for y and in no fractions? Does that make sense? And we can do it this way if you want to. So we can go, you guys agree that 6x minus 9 would equal negative 3y? Does that make sense? Now what could you do? Okay, so if I divide everything by negative 3, that's going to give us negative 2x plus 3 equals y, right? Can I take that y now and substitute it in right there? Okay. So this is kind of the route that we've been working with these. We get 4x plus now 3, and then negative 2x plus 3 equals 6. Now remember, when I solve for y, like Travis told us, the first thing we're going to do is divide everything by negative 3, right? What's the first thing I'm going to do here as I substitute and I try to solve for x? What are you going to multiply everything by now? Or at least in that left-hand side, what's the first step that you're going to do? You're going to distribute. So you're going to put back through, ultimately, that 3 that you just took out through division a moment ago, right? So if we can recognize that, maybe that's something that we can think about maybe not having to do, okay, eventually. I'm going to go ahead and solve this. I get 4x. Distribute, I get negative 6x plus 9 is equal to 6. So you get negative 2x plus 9 is equal to 6. Combine like terms. So now subtract 9 from both sides. Get that? Does x become 3/2? Okay. Now we can go back and solve for y. Now that I know that x is 3/2, come back in here and say, okay, well, negative 2 times 3/2 plus 3 is going to equal y, right? what's going to happen with that negative 2 right there and that 2 right there? One's in the numerator, one's in the denominator. They cancel. So it leaves me negative 1 times 3, which is just negative 3, plus 3 would give me my y, which is going to be 0, right? So y is 0, x is 3/2. And that's what I get for my solution. Okay. Yes?
I got from after the 4x minus
Yeah, so here, that went to that term right there, negative 2x, right? I haven't touched the plus 9 or equals 6, so those just carry straight down. And now remember, I'm trying to get the x's by themselves. So I took this 9 and subtracted it from both sides. So 6 minus 9 gives me the negative 3. And that's fine, right? We can do it that way. That's the kind of the way we've been talking about doing these for the last, basically week. Let's do this real quick. 4x plus 3y equals 6. And we had 6x equals 9 minus 3y. When we first did this, we ended up subtracting 9 from both sides, and it gave me negative 3y, right? Okay. What if I multiply everything by negative? Does that make this a positive, that a positive, and that a negative? So right now it's negative 3y, right? If I multiply by negative 1, it makes a positive 3y, right? But then I multiply everything by negative 1, so it does that, correct? Why would I want to do that? Now it's telling me that a positive 3y is the same thing as negative 6x plus 9, right? Do I have a positive 3y right there? Yeah. So let's make that substitution. Let's rewrite this thing as 4x plus, now 3y, we were saying, is negative 6x plus 9 is then equal to the 6 that is in that equation. Does that right there get us to the same point that we were up here? Okay? So the idea there, the debate, and I said this when we were doing it the first way, is that we divided by 3, but then the next step is actually to distribute a 3 back through it. So we can kind of maybe bypass that by recognizing that substitution there, okay? On Monday, I'll show you a completely different way of doing that, which is actually a lot quicker. But when you substitute, we're always trying to find like a 1y and plug that in for something, or a 1x and plug that in, okay? But if you want to it makes sense to substitute a 3y with something, or a 2x with something, or a 5x, or a negative 10y. If it makes sense to do that, if you know what negative 10y is equal to, go ahead and make that complete substitution. Does that make sense? You're replacing two things that you know are equal. If you are at some point going to say 3y and negative 6x plus 9 are equal, then wherever you see a 3y, you can replace it with negative 6x plus 9. Okay? So that's just trying to, in all topics that we talk about, we've got people that are, I don't know if I said this yesterday, but say 15 people in here. We've got 3 levels of proficiency with this stuff. We got the people that are just the basic level, we got intermediate, and then we got the advanced, right? I think this is a step, this is a procedure for those that are kind of at the top, okay? This might be something that kind of allows you to learn a little bit more than just the things that we've been doing, all right? Let's do this. So nobody has seen these yet, and I want to make sure that when you're doing these types of problems, you don't come across some stuff that you think, what in the world, I have no idea what is going on here because this hasn't happened yet, but this can happen. Now, they're not abundant, okay, but they do pop up occasionally. If I have 2x plus y equals negative 3, that's equation number 1. And then we have 2y plus 6, and that's equation number 2. Or say equals negative 4x. And it does make sense sometimes, maybe, guys, and we'll talk about this later on, maybe labeling these equations. Instead of having to talk about the top equation as the top one or the bottom one, I just say equation 1, equation 2 by number them that way, right? That kind of makes sense? So you might see that in some textbooks. So if I look at this, what equation there has a variable that would be really easy to solve for? Lindsay? Equation 1, and what variable would you solve for? Solve for y. So let's do that. What am I going to have to do in order to get this 1y by itself? Subtract 2x. So we're going to have y equals negative 3 minus 2x, right? Okay. If you want to write that, some people write that as negative 2x minus 3, right? You can move those around. You can use commutative property, but that's what we're looking for y. Okay. So now that I know that, can I come down here and replace that y? So let's do that. So I'll have 2, replacing that y then with negative 3 minus 2x plus 6 equals negative 4x, right? And here's the thing, this is where, like, as you're working, you want to be kind of confident that you've done everything right. If you know all your rules of algebra, you know your rules of substitution here, we should know that right now we have done absolutely nothing wrong, correct? Because I want you to make sure that you understand that when you get to a conclusion here in a moment, that nothing was conducted incorrectly to arrive at this conclusion. So if I start to do what next? What would be the next, you're going to distribute. So you're going to get negative 6 minus 4x plus 6 equals negative 4x, right? Now what are you going to do? Lindsay? Combine like terms. So what's this negative 6 and positive 6 going to do for us? They're going to go to 0. So then you're left with negative 4x equals negative 4x. Okay? And you could stop there because the left-hand side equals the right-hand side, right? Yeah. Or you can keep going. If I was going to keep going, what algebra would somebody maybe do next? Add 4x to both sides. Okay? You also have so that would give me 0 on the left, right? And 0 on the right, correct? You also, maybe some people say this, divide both sides by negative 4. If I divide by negative 4, divide by negative 4, I get x equals x, right? And then some people that do that might say, they might stop there, or they might go further and say, well, subtract 1x from both sides, but still get down to 0 equals 0, right? But you're going to stop at 0 equals 0, x equals x, negative 4x equals negative 4x, whatever. And what I want you to understand is that's different than what we've been doing, right? All the questions you've done so far, you get down to like x equals some number. Here, all the x's went away, and you're left with an argument that you have to justify whether it's true or false. Does 0 equal 0? Yes. Okay. So we come up with what we call a true statement here. Now, like I said, if you were to stop here, you would ask the same question: does negative 4x equals negative 4x? Then that would be true, because no matter what that's saying is, no matter what x is, I multiply the left one by negative 4, I multiply the one on the right by negative 4, doesn't that end up being the same? If x is 1, negative 4 times 1 is the same as negative 4 times 1, right? And we can do that over and over again as many times as we need to with whatever x value. So it's showing you that no matter what x value you choose, you get a true statement. Okay? Annika, what did you say before when you got down to this? Huh? Were you doing something you shouldn't be doing?
No, I was just playing with my hair.
Getting bugs out?
No, I don't have bugs in my hair.
All right.
No, I don't.
So if you get a true statement, you said that meant that we had infinite solutions. Infinite solutions.
Yeah.
Okay? And now the reason we have infinite solutions, think about how you did this here. You said you solved that one for y. Let's solve this bottom one for y. If I'm going to solve this bottom one for y, what would you do to both sides first? So you would end up with 2y equals negative 4x minus 6, right? Then what would you do? Divide by 2 to everything. So I'd end up with y equals negative 2x minus 3. Is that equation, now the order is different, but is that equation going to do the same thing that one does? So if you graph this one, get a line, and then you blindly graph this one, you will graph the exact same line twice, right? Okay. So does that mean they intersect all the time? And that's what we're looking for. So if I were to ask you, like from 6-1, graph these two lines, and you graph them both in Desmos or whatever you're going to use to graph them, and you graph the first one and the second one overlaps on it, you know you're going to say they intersect all the time. They intersect at an infinite number of values. If we're doing the algebra, like we did here, there's no graph up there, right? Okay? So what we need to realize then is that when the identifier to tell us that the lines are identical, that they do indeed coincide, is that we're looking for that true statement. Okay? 0 equals 0. It might be at some point you might get like 3 equals 3 or 15 equals 15. It's just a number equal to a number. Does that make sense? So that means we have infinite solutions. So we've seen examples so far where we get one solution. We've seen infinite solutions. You guys remember the other type of, we could have no solutions. So let's see what happens with equations where we get no solutions. All right, so if we look at that system, which equation 1 or 2, do you want to manipulate? Do you want to solve for a variable? First one, okay, so what variable do you want to solve for? Yx. Okay, so they both have a 1 in front of them, but the y is negative, and we'd have to do one more step to solve for y, right? So let's just go ahead and solve for x. And maybe we haven't done a whole lot where we solve for x, but it doesn't matter what variable you isolate. So you're going to add y to both sides, right? So x is equal to 6 plus y.
There, good.
Okay. So now you're going to take that, and you're going to put it right there for that x, right, in the other equation. So when you do that, you get 2 times 6 plus y minus 2y equals 4. What do you do from there? So you get 12 plus 2y minus 2y equals 4. What are you going to do next? Combine like terms. So what do these terms go to?
Y, 0.
0. So you're left with 12 plus 0, right?
What? No.
Because you got this 12 right here.
Nothing.
Well, no. Oh, okay, so when I say 12 plus 0, you're just going to write 12. Is that what you're saying? Yeah.
Okay.
So 12 equals then 4, right? And that's like the last one, so that's false. Okay? And that's the thing. I want to make sure we understand, because you didn't do anything wrong there, right? But that's a weird thing to show up when we work an equation, and we're thinking we should get x's back, and like x equals or y equals whatever. And I don't. A lot of people look at that and say, I did something completely wrong, and they erase it, and they try something again, and they usually get to the same thing, and they think, I can't get past this. I keep getting the same thing. This tells me something. I have to ask myself, is that true or false? This is false. So a false statement yields no solution. Sometimes you might see it written that way as we've talked about that being like the empty set. Just circle the slash through it. It means there's nothing that will work, okay? So there's not a single x or y value, or x and y value, that you can plug into the top equation that will give you 6, and then that you plug into the bottom equation and it give you 4. Does that make sense? You might be able to say, okay, well, if I go 8, x being 8 and y being 2, that'll give me 6. If I plug 8 in here, I get 16 minus 4, that gives me 12, right? So not the 4 I'm looking for. So that's the idea. That's what that false statement is saying. No matter what you choose, you might get a point that works in the top equation, but it won't work in the bottom. Or you might get one that works in the bottom, but it won't work in the top. No point ever works in both of them. Is that okay? So no solution, infinite solutions, or one solution. And that should all kind of parallel back to what we saw right here in 6.1. Where's that? 6.1, when we talked about graphically how one solution, no solution, or infinite solution should look to us. Okay. I want to do one thing real quick. If I gave you, and this is just going to introduce us to what we're going to do on Monday. If I gave you something like this, so let's go 3x plus 4y equals 8, and let's go 2x minus 4y equals 12. Okay. If I were to solve either of those for x or for y, okay, now the bottom one is not terrible. Can I solve that bottom one for x pretty easily? And it'll give me like 6 plus 2y, right? Okay. If I look at the top one, now if I solve that bottom one for y, I'm going to get some fractions, right? I'll get like negative 1/2, actually be positive 1/2 x plus 3, okay? I don't like that fraction of 1/2. Look at the top one, though. If I solve that top one for x, I solve the top one for x, it's going to look like this. It's going to be x equals, it'll be 8/3 minus 1/2 y. That's ugly, right? Or if I solve it for y, I'm going to get 2, so divide everything by 4, so that'll turn into 2, and it'll be negative 3/4 x. That's still pretty ugly, right? Still got a fraction there. So what we find out later on Monday is that there's another way, okay? And this is the idea I told you, like the tool shed and digging a hole. If I've got a pitchfork, a shovel, and a spoon, we're going to use the shovel, right? Well, this question says basically, well, what if I have like a backhoe in my shed? I would probably want to use that then, right? Does that make sense? I'm going to get my hole dug a lot quicker. And this is kind of the backhoe for these types of problems. If you add straight down, how many x's would that be? 5 x's. If you add straight down, how many y's does that give you? 0 y's. So the 0 times y is just 0, right? So I'm not going to write anything there. They went away. What's 8 plus 12? 20. How do you solve for x there? Divide by 5, and I get 4, right? So x is 4. So if I were to graph these, they're going to intersect in an x value of 4. Now the only thing is, I now have to plug that back into one of these equations. So it doesn't matter. So I'm going to go to the top one. Get something like that. So I get 12 plus 4y equals 8. Subtract 12. Get 4y equals negative 4. Y will be negative 1. And that is a process that we'll spend a lot of time on Monday and Tuesday and Wednesday next week deciphering and working through. But that is much quicker than solving for y or anything like that, or solving for x in any of those equations. You can do that with anything that we've done so far. It just means that the ones that we've done so far might not necessarily be set up the best way for that. You know, there's a certain thing that we have to set. Our x's have to be stacked on our x's and our y's on our y's and our numbers on our numbers, or constants on constants. That will work for any situation. Okay. As long now the neat feature here is that the y's went away, right? So I would need to have some equations, or have the ability to maybe change my equations so that I get either my x's to have coefficients that are opposite, or my y's to have coefficients that are opposite. So that'll be Monday's discussion. What I want to do right now is going to give you the rest of this time to work on that worksheet that I gave you that is due Monday, questions 5 through 12. If you want to bounce ideas off of one another, you want to ask me questions, we can do that. That's the plan. No new homework this evening.
Yeah, thanks.
Extend your 6-2. Is it 6-2?
Yeah, halfway done exactly.
Okay.